Okay, hello. Hi, everyone. Welcome to the session. Today, we are going to talk about AI factories. And my name is Yabodee. You can call me Tan. I'm the Chief Data Officer from SCB DataX. And today, I have a special guest, Terry Yin. He's the Senior Data Scientist and the Deep Learning System Architect from NVIDIA. Hello, Terry. How are you?
Hi, Abdi. Abdi. How are you? I'm
good. Okay. So before we get started the session, maybe you can share a bit about your background and your role in NVIDIA.
Sure. Hello, everyone. My name is Terry. Basically, I'm a solutions architect that works on AI factory projects and large-scale AI data center readiness preparation, and also the deployment and all the way to the customer success. I'm based in Singapore, and I mainly work on the project that is growing really fast in our region, including some of the big projects in Thailand as well. Very happy to be here and to support this event. Thank you, Kunapati.
Good. So I think for today's topic, it is about AI factory, right? Which I can recall that this is the term that Jason Huang, who was the CEO of NVIDIA, has defined it, that AI factory is actually like the future of data center. So can you help us understand a bit more about why the enterprise really need to shift the thinking from the traditional data center to AI factory? What's the key change that driving this?
Yeah, I think this is a very high level but visionary way of describing what is happening and what actually all the modern enterprises should be made ready. In order to make ready, they are prepared to prepare for the future giant impact of AI evolution. I think the impact of the technology itself definitely has been witnessed by many people already. And the reason, I think AI factory is one of the building blocks of the future AI technology impact and evolution. But I think it's also one of the most fundamental building block. That's why Jensen has been putting it this way. There are a few reasons. One reason is because compute definitely is a new productivity measurement in the future for AI revolution, and the way that compute can be organized and provided to support such evolution is in a way as if that we are creating the modern factories. That's why I think we are talking about as a AI factory. And the second reason is because we already have a lot of data centers actively been prepared or has already been put into operation in the past decades because of the previous two generations of IT technology evolution. The first one is a mobile computing based technology evolution, and the second one is cloud computing based. And in order to fulfill the requirements of these two X generations of IT technology evolution, we already had a lot of data centers deployed, much more than the time that when the internet just gets started. But the challenge still remains because even though we already have data centers, but it does not necessarily mean that data centers are already ready to support and especially to host what is necessary for AI factories. Let me give you an example. Like in for typical cloud data center, the typical per rack maximum power power density is about 3 to 5 kilowatt. This is a very typical and also widely adopted number for cloud data centers. But the threshold, the minimum power density requirements for deploying a proper modern AI factory that can support the large language model-based AI application well is minimum 10 kilowatt.
Mm-hmm.
So, this is still not the biggest gap, to be honest, because in order to retrofit the traditional cloud data center to be able to support 10 kilowatt power density, I think that the amount of effort is great, it's a lot, but still it's doable. That means you do not need to build a brand new one. Even on the ground field, you can actually transform your pre-existing cloud data center to support the bare minimum of AI factory.
Mm.
But from last year, I think we're all seeing the exponential increment of the power requirement on the modern AI infrastructure. For example, NVIDIA's GB200 NVL72 rack level system, it requires 125 kilowatt power density, and it's almost like 20 or 30 times of the typical maximum power density of cloud data centers. This is just an example, but I'm just trying to give people an idea that why the traditional cloud data center is still useful, but we need the data centers that can actually has this capacity to host the modern and future AI factories.
Understand. So maybe can you help guide us a bit in terms of key decision factor, right? Because many of the enterprise right now probably use their data center in the cloud services already. But what makes them need to think about changing or building their own AI factories versus cloud service?
Yeah, I think this is a very common question, but it's very critical. To be honest, I think we were all already, I'll say, been through the entire journey of everything was just on-premise to everyone was talking about cloud first in their company and enterprise IT strategy. And now it comes to a time that we need to make another decision for big change, right? So I think in general, the guideline definitely is that we need to first of all make sure we understand that the key factor that decide whether the infrastructure should be on cloud or on premise are mainly decided by three factors. The first factor is whether your data or your entire data processing pipeline from the source of your data all the way to the output of the data is heavily relied on cloud or it's actually flexible, because a lot of enterprises data processing pipeline, they are already cloud native. It takes time to change, but this is not the most critical question, because we always encourage to focus on what is most critical for AI compute infrastructure. So the second factor that is very critical is whether the cloud can provide you the sufficient compute power. So this is this question sounds like something that comes from nowhere, because traditionally we would always assume that there are infinite amount of compute resource on cloud available. We are just subscribing to a very small portion of the large amount of hyperscaler level compute. But when we are talking about the compute power needed for AI infra, we are talking about a very special kind of cloud compute instances that not only are equipped with modern GPUs, but also are interconnected with with a cutting edge networking capability. And the first factor, the compute instances equipped with GPUs are not rare to find, but not too many traditional cloud service providers are able to provide a cluster like a subscription that has all the GPU compute instances interconnected with a cutting edge networking. And the cutting edge networking is extremely important for combining the compute power of all the individual GPU servers together for big tasks such as training parameter training, model training, or even larger scale testing of like a scalable deployment of inferencing services. So that's one of the reasons that NVIDIA has been working so hard trying to share whatever technical best practices in terms of building these cloud services to all the major cloud service providers, including those new clouds. So that is under the NVIDIA Cloud Partner Program.
I see. So is this about the scale as well? Like the company that probably will need their own AI factory would need a big scale work that they are going to perform, right?
Yes, this is also relevant to the scale. Of course, I think the scale actually is reflected as amount of data actually can be generated, which is relevant to the first question normally. Of course, there are other example that does not goes into this category. For example, we all know that before some of the big internet companies, they are surprisingly small scale in terms of number of employees, but they have a lot of data. For example, Twitter. But yeah, these are the very rare cases. Most companies, the real side thing that matters to the AI training actually is amount of data, preparation work that is necessary, that is associated to the amount of data they generate or they need to process on a daily basis.
I see. From your experience, any like most common misconception about AI infrastructure that you have heard from the company that they are planning to deploy AI scale?
Yeah. Well, I think. Yeah, I think I'm seeing the following few misconceptions. The first one is a lot of companies they feel that they can wait until the AI technologies become fully mature and start to subscribe it as if they are subscribing to electricity. I think this assumption is has some problem in the sense that AI compute, what AI compute actually is trying to bring is evolution to the way that intelligence can be generated. So unlike electricity has nothing to do with your company's business secret, has nothing to do with your data, right? Even internet is actually just a communication tool. You can subscribe it and in whatever way you want, or you can subscribe from whatever internet service providers you prefer. It does not have anything to do with your business secret, your the data that you have all the way inside. Even though you just switch the service provider every day, your entire service just continuously runs, right? But for AI, the fundamental differences is that first of all, in order to make AI really powerful and can help you improve your productivity as much as you can, you really need to let AI learn your business logic, your data, and in this way, actually, this is a process that your company in-house engineers and data scientists will practice and grow their skill sets together with AI. And this whole journey takes quite a long time. And because I've been working on AI since 2015, like it's been a not so very long journey, but I think it's long enough for me to witness some, like a couple of generations of changes of AI technology. Those data scientist engineer that started working on the first generation of modern AI, which is called deep learning, they are the one that has followed the whole journey, and they are the one that can learn and pick up the latest technology fastest of all, and also put them into productivity fast of all. And those who claim they had enough training, actually, they still are just catching up. So so the idea of subscribing to AI infrastructure is not just about whether you are making the infrastructure hardware, software or not. It's actually really about whether you are making ready a team of a team of talents that can help you transform your investment of infrastructure, investment of data into the return of your investment. That's actually the key point of entire journey.
I see. It's not just only technology or technical part of it, but also business part of it. Yeah, I see. And
right.
people.
It's about your in-house capability.
All right. Understand. So let's shift gear a bit to be more technical, right? So I understand that when we are trying to run like big large language model, like the trillion parameter or even the real time kind of model, what are the core technical challenges that mostly the company faces? And I understand that NVIDIA has invented a lot of technologies that address those challenges. Can you share a bit about those things?
Yes, definitely, because these are the pain points that we are working on, and also trying to optimize on the architecture design level on daily basis. So there are a couple of challenges, and I will talk about why NVIDIA, in response to these challenges, how NVIDIA's architecture actually is designed and focus on to address these changes. Okay, so I think just in short, the biggest issue about training very large language models, like trillion parameter level models, is really about how to make sure your training can actually run stably and continuously without interruption. This is a key fundamental factor that is important for training trillion parameter models. Of course, I'm just what I'm talking about is based on the assumption that the way of training the algorithm, the architecture of training the algorithm is more or less mature. And we are really trying to just train a trillion parameter model to get the most value out of our data. What you will really expect is your training infrastructure is continuously running without any error. And when there's error comes up, your training infrastructure can be resilient and can resume back in the soonest possible time. This is actually the most critical part, and actually is the biggest pinpoint of all the trillion parameter model training cases. There are a lot of challenges here, and I'm just going to quickly touch on how NVIDIA's Blackwell Ultra and also the 5th generation NVLink can address this issue. Okay, so Blackwell Ultra. I just mentioned, right? So the biggest issue is whether it can continuously train the model. There are a few challenges behind stably and continuously training infrastructure. One of the biggest one is whether the GPU accelerator, which is a key horsepower provider, and all these softwares built around this GPU infrastructure actually is stable enough. Blackwell Ultra is the technology that is a technology miracle that NVIDIA built to fulfill these requirements. In order to make it extremely efficient, we have basically optimized Blackwell Ultra into a AI specifically optimized accelerator. And in this way, we have basically get rid of everything that is not necessary for AI and try to amplify everything that is important for running training and inference on Blackwell Ultra. Even compared with Blackwell, we have made a tremendous change. Okay. The second one is NVLink. One of the biggest challenge of, let's see, allowing your whole infrastructure to run stably and also resume back from failure is your networking. You need to, first of all, have a very reliable and cutting edge bandwidth networking so that your training can run reliably without having frequent failure. And in case any failures comes up, you will also want to have a fast enough and also cutting edge speed network so that you can load your like terabyte size model from your storage as a checkpoint back to a GPU. Let me give you an example. We are talking about loading like a 1 terabyte model simultaneously into 1,000 GPU servers. You can imagine the amount of bandwidth needed in order to make this work. And this is the elephant flow actually we are seeing on the infrastructure. And you will need to have the cutting edge infrastructure so that you do not need to just sit there having one coffee, another coffee, hoping that the whole thing the loading process can finish soon without running into any failure. My whole thing can restart as soon as possible because you already have like 100 million, hundreds of million infrastructure already invested there, and you are having, for example, you are having a deadline for this cadence or for this milestone you want to meet so that you can hand over something out and let the customers test out and give you feedback or like just sign the contract. That's where the whole process pressures comes from, and that's why the fast networking infrastructure is important.
I see.
Just going to give you these two examples.
So other than like this robustness and scale, the real time, also the latency on how you make sure that the model is be able to achieve the throughput optimization. What's the infrastructure design that you kind of like make sure that the NVIDIA also provide a solution to address this issue?
Yeah, I think this is a very good question. So thank you. Exactly. So it's I think achieving a reliable and also high performance infrastructure is not easy. It's quite challenging in the sense that you need to both understand how the application works, first of all, and you also need to understand how to make sure the application can run stably over time.
Mm.
So that means you need to understand the workflow. Basically, you need to understand the basic workflow of the application, so that you know that what are the hot spots in the entire workflow, and what are the optimization where you need to actually put your optimization effort in your architecture design. And second part is you need to know that on some of the parts, even though it might not be a bottleneck, but it can get into problem easily, and it can break your entire workflow, your productivity. So these are the two factors that we typically would take into consideration. And NVIDIA understand that the technology is just evolving too fast. And the market, however, needs working technology so urgently. So what we always do is we always trying to share NVIDIA's best practice in order to everyone, so that the ecosystem can grow autonomously, and the technology can evolve as fast as possible. And these best practices, we generally call it reference architecture. So NVIDIA has many different reference architectures tailored for different designs. And this is why we design these reference architectures, keep it evolving like on monthly basis, continuously collecting feedback from our internal and from the market, and also from the technology ecosystem community, make it better.
I see. Since the interest of time, I think that this would be the last questions. Looking ahead, I think that maybe you can help suggest a bit about the enterprise, especially like, for example, SDVX, right? How do we want to thinking about invest in and having AI factory? What's your suggestion?
Sorry, could you repeat the question again?
Yeah. I think that looking ahead for the enterprise, to be thinking about AI factory investment, what would be the suggestion for you for us to get started?
I would not be surprised I'll be very surprised if you haven't actually tried any AI model yet. I believe you already tried, and you have a lot of your team members has already tried to gain some experience on AI models. I'm not talking about just subscribing to ChatGPT or Google Gemini. I'm talking about really doing it in a professional IT way or in a data scientist way, right? So I believe you already come up with some idea what is currently most suitable model for your business or internal demand, and why it is most suitable, and down the road, whether you are going to adopt the same model families roadmap or you are going to develop your own ones. These are the three fundamental questions that will help you answer what is the current sizing of technology of the AI model you are looking to run for production. and what is the advantage that make you decide to use it? And in the future, what are the sizing of the model that you want to have it trained in your own infrastructure or by your own team? I think these are the three questions that are most critical. But in general, and I would like to highlight that one common question that people often will ask and sometimes will make mistake is when the model, you find a suitable sizing model, you actually find it very useful for your use cases. And then you feel that it's suitable, but actually it haven't been extensively studied yet. There are a lot of use cases for all these models. And one suggestion is always find a reference size and architecture and also family of models. Start from there and make sure this starting point is thoroughly tested and start research. So you know you are starting from a right place, and then stick to this family, stick to some roadmap, and try to set up milestones and also the target alongside the roadmap of this model family. And then you'll easily get the reference and anchor point so that it will lead to a mapping of the sizing requirement to our infrastructure. It will automatically come up with the sizing. So the key question is still which model you want to use, how many people you want to serve, and what is the performance and the experience, AI application usage experience of your model that you want to provide to your end user.
Noted. Okay, sounds good. Thank you so much for the time today, Terry. Glad to have you here with us. And thank you everyone for listening.
Thank you,
Thank you.
Thank you.
Okay, bye-bye.
Bye-bye.